Welcome back, folks. Another nodal analysis problem for you. We're going to do two things that are a little different. I'm going to add a second source, which is, I think since we've gone through mesh analysis, I think you're confident now that these methods of analysis can use multiple sources, whereas the seat of the pants method, you're going to have a little bit of trouble with that. There's another way to do it we'll get there when we talk about theorems. The other thing that I'm going to do differently here is find a voltage as the output instead of the current, which is going to be similar to how we found voltages from node voltages in one of the first videos in this section. But since you're just starting out with nodal analysis, I think it's worth looking at one more problem. It's pretty similar, but it's got an extra source, and we're looking for a voltage as the output. So without further ado, let's get to it. Okay, looks like that. I put it over my head this time. We'll see if this works nicely. That way I can just kind of write down along here. Okay. So let's see. I'm going to label my non-reference nodes. Okay, so I've got 3 non-reference nodes again. So I'm going to label them there. This node down here is ground, so that is the reference node. A, B, and C. And I'm going to label passive current directions. Okay, this is active and that's active. I can't change that. But passive current directions, I'm just going to pick a direction. Now, when I have a voltage I'm finding, I like to keep it consistent with passive sign convention. So I'm going to make that right because that's going to match passive sign convention. It's going to make it harder for me to screw up little things and get a sign wrong somewhere if I do that. So that's my habit, and I'm encouraging you make it your habit as well. Not necessary, but also not a bad idea. Okay, so we're going to write KCLs for each of these. I'm going to move a little quicker. KCL for A. I have 2 things connected to it, so it's going to be 2 milliamps flowing into it. That milli is important. Don't drop it. You're going to be tempted to write 2. And that 4K is important as well. Okay, so I got 2 milliamps going in, so that's plus, and minus VA minus VB over 4K, and that's equal to 0. Okay, let's rearrange that right now and say negative 1 over 4K VA plus 1 over 4K VB is equal to, and we got to move that 2 mils over, and that one's good to go. A little quicker, right? Okay, I'm following the steps. I might be doing a couple in a row here, but you got to get faster. Okay, we're going to have these on exams, and if you're working, you're going to have deadlines you got to meet as well. So you got to get it done quick, and you got to get it done right. KCL for B. Let's see here. I got 3 things connected to it. VA minus VB over 4K minus VB minus 0 over 2K and minus VB minus VC over 4K, and that's all of them, so that's equal to 0. Okay, so this is the current through R1, this is the current through R2, and this is the current through R3, and the signs match the direction of the arrow as they relate to node B. Okay, so breaking up and rearranging again, we got 1 over 4K VA plus we got negative 1 over 4K. Simplifying this gets a little sloppier, and most times I'm going to let the calculator chew on it. Anytime I can have the calculator do arithmetic for me, that's my preference. If you're in class and you have to watch me do arithmetic in front of you, it's a sight to see, let me tell you. Okay, so then let's find the VC term, and we get plus 1 over 4K in front of VC, and that's equal to 0. Okay, like I said, I'm going to let the calculator chew on that. Other than that, I would say that's good to go. Okay, let's come over here and write the KCL for node C. Okay, similar to node A, it's got a supply and a resistor, so I'm going to end up with 2 terms. Going into it, I've got VB minus VC over 4K, and I got 6 milliamps leaving, so that's equal to 0. Just got to break this up and move that over. It's behind my head. Bye-bye. So we end up with 1 over 4K VB minus 1 over 4K VC, and that's equal to 6 milliamps. Okay, so I'm happy with that one. And there are my 3 equations. Okay, a little faster this time. We're getting quicker, right? All right. So we got to get this in matrix form. So, hey, I'm back. Let's see. We got a 3 by 3. Every color but the one I want. There we go. Okay, so we're going to get negative 1 over 4K. 1 over 4K. And 0. Okay. We're going to invert this matrix, and then on the right-hand side, we're going to have negative 2 milliamps. Always keeping track of those SI prefixes, because that's a good way to be off by a factor of 1,000 at least, if not more. So the game I usually play with that one is, do you want me to pay you $1,000, or do you want me to pay $1? Okay, so that SI prefix makes a big difference. Okay, do you want your tuition to be? Never mind. We're not going to play that game. That's just, I don't want to make you cry. I would give this stuff away for free if I could. I promise you. I got to eat too. Okay. Anyhow, 1 over 4K, and then I got all this mess. Oh gosh, I got to cram that into this little space here. Negative 1 over 4K, negative 1 over 2K. I made a decision, and now I have to live with it. 4K. Okay, so that's all the second column there. And we got 1 over 4K in front of VC. Right hand side is 0 for that one. Last one, what's the coefficient of VA? It's not there. Be really careful with that. That's an easy way to screw up your analysis. And we get 1 over 4K and negative 1 over 4K. Okay. Right hand side is 6 milliamps. Alright, if I invert the matrix and I multiply by the vector, I'm going to get a vector that corresponds to my unknown node voltages. Okay. It's going to be close to my head. And we got to do that on the calculator. Okay, so go ahead and try it on your calculator. And it's a little trickier with the fractions. Find the invert button is what I'm going to tell you. The little raising things to the -1 helps me a lot. Okay. Also, not forgetting the negative sign helps me a lot. So negative 1 over 4K, 1 over 4K, 0, and negative 2 mils for my first one. For positive 1 over 4K, negative 1 over 4K, negative 1 over 2K, negative 1 over 4K. Feeling good about that. Okay. Oh, that's just 1,000th. You might have figured that out already. 4K inverted and 0. Okay, almost there. 0. I'm a little slower, can you tell? But I'm also going slow so that I make sure I enter it correctly. Because the other way to screw up your analysis is write all of your equations correct and then screw it up, plug it into the calculator. And that's just, that hurts, right? We don't want that to happen. Okay. That is a really small number. It is so small, I'm going to call it 0. 700e negative 15. I'm going to call that 0. Because it's very small compared to my other answers, which are negative 8 volts. It's behind my head. Let me scooch over here. And negative 8 volts and negative 32 volts. Okay. Now I have my node voltages. Same as we did before. It had a second supply. We handled it no problem, right? Second supply, not an issue. Seat of the pants method, bit of an issue. It lengthens out your analysis. Nodal analysis doesn't flinch at it. And that's one of the reasons I love both mesh and nodal. Okay, now we got to find the output voltage. So I'm going to scroll up because I can't remember where it is. Okay, and it looks like it's labeled here. And we play the game that we did when we were using the node voltages to find other values. I know VB now, and I know VC. The plus is over here, the minus is over here, right? It's a KVL, but we're going to write it quickly by saying plus VB minus VC. Okay, so let's get that down here. So V out for this problem is plus VB minus VC. Okay, and then we take these values and we get them down here. So it's going to be plus -8 minus -32. Okay, so that's going to end up being plus 32. And I had that moment of like, I could do that in my head. And then I was like, I'm going to screw it up if I do it in my head. I'm recording a lot of these videos, okay? I'm getting a little tired over here. I had it right. It is 24 volts. All right. So there's another example of nodal analysis. Just a little repetition for you. It can handle the second supply. We can use the node voltages to find voltages if we want to. And that's what we did. There's some wrinkles, okay? Just like with mesh, there's some special cases. See if you can guess before you start the next video. See if you can guess where the special cases come into play for nodal analysis. That's where we're headed in the next video. Okay? Stay tuned and good luck.